Great. So we're happy to have a woman to come and visit in person and tell us about this beautiful work of this affine superfiber and
Okay, thank you very much. It's a pleasure to be here. Thanks for having me. Most of this talk will be based on Pablo Boixeda Alvarez.
Michael McBreen and Zhiwei Yun. And there is a paper. I will mostly talk about the paper which is not out yet, but hopefully will be soon. And there is, I will refer, I will also mention results from the paper that is on archive and will be published soon. Okay, so this being an informal seminar, I'll start with initial motivation and so something that I started on with Michael many years ago is attempt to prove an example of homological mirror symmetry where on the B side I want to have T star of G mod B, which I occasionally call N-field. So of course here G is a say semi-simple complex group, B is Borel, so this is a flag variety, and so this is well the symplectic variety, which is a cotangent to the flag variety, and we can think of it as a resolution of the nilpotent cone. So it's an example of a symplectic resolution. Yes, and X check. So this would be my B side, and this is corresponding category of the coherent sheaves appears in many constructions in representation theory. I will recall this a little bit in a few minutes. And X check. So this is my candidate for X check. So this should be some subvariety in the Langlands dual. Maybe the fastest way to say it is that it's a generic Poisson leaf in the Poisson dually group to G check, which is, but more precisely, it's so I take some orbit. So it's G check. Well, it goes to G check mod W. And here I take some S generic. So then I take G check S is the fiber over S. So this is just a regular semi-simple orbit. I fix the eigenvalues to be distinct. And so now I take an open subvariety here, which is the intersection of this with the open Briard cell B plus B minus. And so so this is my A side. And there are reasons, I will probably don't want to describe all the reasons, but there are reasons to expect that the category of coherent sheaves here that I care about should be compared to the Fukaya category here, and some objects presented by special Lagrangians, etc., etc. So maybe one remark is that here there is actually a family, well, X check sort of, I can temporarily introduce the dependence on S, but up to as a symplectic variety of an isomorphism is independent of S, but the same. Same, yes, sure, because dimensional G and G check. So it's dimension minus rank, and dimension and rank are the same for G and G check. This is an old proposal which appeared in some talks and maybe in print. Yes. So this is kind of rational version of cotangent. It's the same dimension as, I could write cotangent, have the same dimension, but this would be a different geometry. So just, okay, one feature that should be I just want to point out at that stage is that we can vary S. So S varies in the part regular simple mod W, and so we can get pi1 of that thing, well, orbital pi1 in general, which is perhaps extended affine break group acting on the corresponding Fukaya category that's checked by monodromist, and the action. So B affine, it also acts on the B side on DB core T star G mod B, which has been constructed in the context of my work on representation theory, in particular in positive characteristics with various collaborators. So maybe I'll mention the reference to my paper with Simon Rich. It's also related to my work with Merkovich. Okay, so in this form, it's still open, although maybe in type A it follows from Mina's results. But I will talk about a result which is close to this and maybe as close as I want to get myself without help from symplectic geometers, but I will make this more precise a little later. Just another, well, I said that this is in general terms that the B side is important for representation theory, but I wanna maybe mention one kind of piece of motivation is that the B side is related to quantum groups. Intervals of unity. Let's see how to say this. So, okay, so I want to make a precise statement, and so there'll be a little bit of technical details and variations. So bear with me. So we can. Yeah. Okay. So we should maybe. Shall we pause the recording while this is cleared? All right. So the good news is we can continue. Okay. I thought it's a large seminar, a large seminar group. Okay, so how I got into quantum groups, right? Anyway, okay, so yeah, let's continue. So yeah, let me make this more precise. So I will need to let's consider also this different version of this detailed, which a universal extension of like T cotangent bundle by trivial bundle. So this is the Grothendieck-Springer thing. So it maps to G mod B with fiber B. And then the thing is that if I take the small quantum group and I take a block, a regular block, and Q, so Q is a root of unity. And I take a regular block, then this is the same as dB on G tilde naught. So this is the derived fiber at 0, but this is Kazul dual. To dB Koch of until that what we started from. So also there are yeah, one can find huh? Sorry, what? Ah, okay. So yeah, so there is an like algebra A, like my so-called non-commutative Springer, so some non-commutative algebra, which is also Kazul quadratic, and then dBA mod is dB Koch G tilde, and then UQ mod is A naught mod, where this is A as over. Sorry about these details. I just want to make statement, and there is also A prime, which is maybe A. And A prime is derived equivalent to N tilde. So A prime can be really called non-commutative Springer resolution, and A is maybe non-commutative Grothendieck Springer thing, and yes, and so A0 and A prime are Kazul dual quadratic algebras.
How old is this story?
This is, yeah, this is not new at all. So this is maybe in this form it appears in my paper with Lachovska from, it's all like 20 years old.
And which
50.
okay.
So the thing is that it doesn't depend on the, so the structure, the principal block doesn't depend on the, there are some conditions on divisibility that it shouldn't be like
Okay.
order of the root should be maybe divisible by 6 or something like this, which may pay and shouldn't be too small, but otherwise it doesn't depend.
The fact that Q is a root doesn't matter at all. Q could be any.
Yeah, that's a different story. So that's a different, maybe different Q. Okay, so yeah, it's 15 to 20 years old. But it's based on like this paper with Arkhipov and Ginsburg, which is earlier than that. But anyways, so so let me mention one concrete fact that's sort of consistent with this, or maybe.
Can I just
Yes.
ask one more question? The fact that these derived categories of A modules are the same as coherent sheaves, is this in the sense of the A mod is endomorphism algebra.
So this is I mean so you yeah, it's like that this is the tilting bundle here and A prime is its endomorphism, so it's the same that here. So it's yeah. Okay, let me not maybe go into giving all the references. Okay, so something specific that kind of supports this is that the center, so remark application. So the point is that it will something that follows from the main result, but has been established by other methods.
And in fact, if you get Resultado, it disappears.
Yeah, there's a theorem. So there's a following theorem. So it's well, it's a combination of this paper, available paper with Pablo, Michael, and Zhiwei, and another paper with Pablo and Shannon Vassero, and Sean and Eric Vassero. Is that if we consider the center of UQ, so this is actually an interesting thing to understand. That this is more or less cohomology of X check. Well, to be more concrete, it receives an injective map from cohomology. So now this X check should not be, it's not exactly the cohomology of X check, but I should take its universal cover and then invariance. So that will be useful in a minute, in a second. So let me just say that this X check maps to T check. And so we can take the universal cover here, and so we get a cover here. So yeah, there are some homology classes just coming from this, and we kill it this way. So we take positive universal cover and take invariance. So there's an injective map with conjecturally isomorphic. It's kind of isomorphism on weight zero part. Weight zero in the sense that on T invariant part. And just isomorphism in type A. So this is consistent with this causal duality because causal duality kind of cohomology goes to pure cohomology goes to the center, and so this is some sort of related fact. Okay, so any questions here?
Maybe just say to make it concrete, suppose like we're in this example until the ST star one. It's just G to the 0 is
Yeah. So well, yeah, there is not. Sure. So if G is SL2, so X is T star P1. So A prime is endomorphisms of O plus O, maybe -1, T star P1. So this is can be described as subalgebra in matrices in polynomials in two variables, which have this form even, odd. And so what else? So the principal block is governed by some Weaver. I guess if I remember correctly, it's like how does it go? So it's EFE is equal to 0, maybe. something like this. Okay, maybe I didn't prepare this, but there is some easy, clever description. And yes, an X check. You can, it turns out to be isomorphic to the, in coordinates, it's the X, Y, Z, where, so you kind of deform Kleinian singularity. So it's X, Y is equal to some generic polynomial in Z and of degree N plus 1, for example. But, you know, you can, and Z is not equal to 0. And so if, yeah, that's an exercise in linear algebra, this is, shows here that this is the same. And yes, and somehow the
What's N?
just N is 2. And so what else? So yes, the category, okay, I started drawing the quiver, but that's not so relevant. But the there are two kind of, if we are looking at the sheaf supported on the 0 section, then this is generated by OR P1 and OR P1 of -1. So these are two spherical.
Question here, how do you see the relation to Quantico and Dirac category?
Yeah, okay. So if you believe this quiver description that you can find in the old literature.
In this setting would
Yeah.
extent. And completely geometrically, yes. The statement that the dual algebra is somehow directly related to category module.
Yeah, you can see it from this quiver if you, I mean, in the old literature, I mean, Anderson, Janssen, Jorgila would have a literature from the 90s you like, so you'll find this quiver description for the principal block in for SL2. Sorry, okay, it's EF and just one EF is equal to 0. That's the direction now. In one direction, the product is 0, in another not. So there are two projectives.
But you should get an affine quiver, right?
No. Well, if you can get, if you consider the additional, if you consider additional like grading, additional torus equivariance, then you'll get like infinite quiver. But it's a little bit different.
Yeah, but essentially, that's one piece of it.
Anyway, so okay,
But,
so
yeah.
let's move on.
And can you say again whose paper should you look at?
For this?
Yeah.
Well, I mentioned there is this long paper, Anderson, Janssen, Zorgel, but maybe there are better, I mean, more accessible. I'm pretty sure ATP is there, but maybe ATP is elsewhere too. Anyway, okay, so
Can I still ask another question?
yes.
This even in type A, your no code guide picks out very special classes of conformal block. They're not.
Yes. No. Okay. So there are also, I just, you know, for the purposes of keeping this talk like within limits, I focused on this case, but there should be plus generalizations where, so one class of generalizations that I was care about is that we replace the left-hand side, so B side, we replace by a resolution of Slodový slice to an important orbit. And then, not sure I know what to say in general, but at least, okay, maybe now I can rethink and say it better, but at least if the important is principle in a levy, if yeah, I think that's right. If E is principle in a levy, which is of course not a restriction in a type A case, then the dual should be kind of multiplicative slice. For such things, we can assign an obvious way nilpotent in the dual group, just take this corresponding Levy, which should be the same variety in type A that you consider in your work.
But we also have this segment for Gold-Raleigh, which may or may not always be quadratic Raleigh. I'm not sure. I don't know that it is, but
yeah. By the way,
what's true is that there are two different ways of generating the category. If you allow not the bounded Dirac category, but arbitrary complexes, then there are two different ways of generating it, which are essentially the Google. But
by the way, on this note, maybe I should mention that it is known that you have these non-commutative resolutions here, which you can just obtain by base change, and these are also Kazul quadratic algebras, and this is our result with Mirkovich, which is maybe the most non-trivial part in all the story with Mirkovich about localization and heuristic conjecture. And it's a remark that in this generality, it's known its meaning the B side to be derived equivalent to Kazul quadratic algebras. Kazul quadratic algebra. AE. So EE is yes, two like nilpotent orbit G of E is nilpotent, and yes, so this is after many years I learned to put accent here. Okay, so the plan, I actually will spend most of. So the idea is that there is this mirror conjecture, but I'm not a symplectic geometry, so I don't really know how to work with Fukaya categories, and so I will. My goal is to present a sort of related result, which from which this should follow modular some general statements about relation of Fukaya categories to microlocal sheaves. So there are such statements in the literature, in particular Vivek has been actually working on this. So my understanding is that technically it doesn't follow. So there are some technical assumptions in his papers that are not satisfied here, but still. So I will spend time just explaining the statement, and maybe the proof. Maybe I'll say a few words in the end. I mean, explaining the statement and the context. So plan is first. So X check fits in a sort of in a generalized non-abelian Hodge theory story. Generalized meaning where if we allow a connection with an irregular singularity. And unfortunately, so this is some sort of Betti space, or maybe depending on how you phrase it, I mean, is equal to M Betti. So unfortunately, the literature doesn't quite cover this case. So, but this available paper in the archive is, we move some way towards having this picture, but it falls short of kind of having an actual hyperkähler structure. And so now, so this is M Betti, but so now we work with M Delbour. So this is some symplectic variety. Maybe there is some infinite type phenomenon here, but never mind. And so containing, well, contracting to a Lagrangian core. Which is well, like L, which is an affine Springer fiber. And so
It was working really complex.
yes, and okay, so maybe since just again, so remark is that no like identification, no like twistor space degenerating like M like Betty to M Dolboy in the literature. But a weaker result is in this, which is, you know, sufficient for some purposes, is in our paper. So the paper on the archive. So in particular, we can construct like, you know, like according to Deligne, there is this easier part of the twistor space, just if you remove infinity. So we degenerate M Deram to M Dolbois. Well, in particular, like we prove it's a family with reasonable properties, in particular cohomology of M Deram. And then M Deram maps to M Betty by Stokes theory. So here, you know, it's not like it's not just taking monodromy of a connection. You need also the irregular singularity. You need to take care of Stokes theory. So again, people who work on Stokes theory are not, many of them are not so interested in general algebraic groups. So the literature is not where we exactly where we need. So for this reason, we only prove it's a bijection, and so we don't say in the paper it's bianalytic. But this is, of course, I mean, put as a conjecture, which should be. I mean, I think it's almost false from Witcher, so hopefully we'll be able to fix that in the later paper. But modulo such technicalities, that's okay. I mean, technically, maybe when I say theorem, I assume that. Huh? So there is, if you think, I mean, there is a, it's not like obvious, but there is some statement like that. So there is a Tanakian formalism used here. You can, yes, we know this idea, so you can reduce it to GLN, but it's just some work to do. It's not like big open question. But so what I want to say here, and okay, I'm just basically advertising that paper, so that's where we are. And so this is more general. We can start, so can sort of deal with any homogeneous affine spring affine, but I will maybe recall this in a few minutes, what this means. And I should say that Betti spaces actually were studied equal to spaces studied, I forget the name that he uses, by Mintam Twin in particular. So he's now postdoc at MIT. He worked on this independently. Okay, so yeah. And then maybe one way so that this one should think about what this is doing is that this M del Bohr is an affine analog, like loop group analog of resolution of the Slotoway slice. So maybe I will say a few more words about it in a few minutes, but basically in the fine dimensional theory, well, there are the spring of fibers, just fibers of this map until to n that already appeared. Then there is this nice slice, nice symplectic variety in which this is a Lagrangian. And for many purposes, one wants to have something that's for affine for loop group, and one does not have it. Well, I always thought that the closest approximation is basically the Hitchin space, where the geometry of the global curve also enters. But it turns out that for this homogeneous cases, there is a close analog. Okay, so but I kind of interrupt myself. I was explaining the plan. So there are two plans, but there is going back to what I started on this board. And so now I'm just so replace the A side by microlocal sheaves on this M del Bohr supported on L, which is full E. But this turns out to be also a category which is, much. Microlocal sheaves is existing but not very well developed notion, but it's this can be identified with a category P and a category, which I will define later, of perverse sheaves on affine variety. And then the final theorem takes shape that, well, in fact, that derived from the category of coherent sheaves on and tilde. So maybe T equivariant, and maybe supported the zero section is the derived category of this category P. And in fact, this A0, this A prime mod is equivalent, well, supported at zero is equivalent to P as an abelian category. Okay, so this sounds a little abstract. Well, it's not just abstract, but I didn't explain what this file E is. So maybe, so this was the outline, but so maybe now I can. Huh? No, some specific that to be defined in a few minutes. Yeah, full subcategory and category of privilege sheaves. There are many sheaves. Yeah, not it's not that the theorem there exists a subcategory. It's not an existence. Certain. Okay, so now I want to start filling details. So first, who is this? So I don't know if I need to recap what the affine flag variety is. Maybe I should, right, quickly. But then I should also say E and who is E and who is full E.
And if you think of your currencies and then tilde is being generated by the tilting bundle, then again, example of Fukaya.
That's it. Yeah. That's right. So these are, well, here we kind of see if we don't like general, I mean, you can generalize using this wrapped sheaves or whatever. But if you do the natural version, then you only see modules supported at 0. But these are
It's obvious.
It's the same. Yeah, it's the same structure that comes from this tilting bond. Exactly. So here it will be. Well, I didn't actually write this down. So the reducibles are like OP1 minus no. It was OP1 and or maybe OP1 of -1 shifted by 1. Sorry, of -1 shifted by 1. Homologically shifted. So these are like two spherical objects, and they correspond to. But in fact, here, these are the corresponding generators in GB called P1. I will actually want there was a steep invariance, so I consider there's maximal torousness also acting. So let me take GB co T of T star P1. Sorry, it's T is just the maximal torousness. So I can start. So the one preserving the symplectic form. And so here then there will be OP1 and OP1, like with the natural, well, they of course have natural cystacoran structure, but there is also, you can twist them by character. Let's use it as an upper index by a character of C star. And then these will be like spherical objects that will be governed by So this is like spherical objects governed by the affine quiver of type P1, and here we'll see the universal cover of the affine quiver of type P1. So the objects are in bijection with the vertices, and the X will be one-dimensionally there, neighboring and 0. And each object is like S2. Self-X is cohomology of S2. Okay, and so yes, so let's first talk about the affine flag variety and the Springer fibers. So this is the loop analog of the flag variety that already appeared. So we take this LG, so it's like infinite dimensional algebraic group or algebraic in scheme of infinite type, as they say. So LG sort of C is G of C of T. And so this is modular of the I. So I is the Lahore subgroup. Namely, it's contained in L plus G, which is L plus G of C is G of So these are maps from the puncture formal disk to G, and these are maps from the actual formal disk to C. And then, so this maps, so L plus G maps to G by evaluation, and so here we also should can be considering kind of the dual. Of course, when I say full, so it's fine flat variety all to dual.
Sorry, so how you can identify that? How would you prove your theorem by explicit calculation and
Oh, how I'm going to prove my theorem? Okay, I thought that this would come in the very end, but no, I can tell you that. Okay, so I define this, and then maybe yes, before defining this, I will. It will just the proof will be actually not so difficult, but no, we'll just prove it. So proof goes formally basically is based on two facts from which it kind of follows formally. Well, kind of. Yeah, maybe just 5 minutes, because I still need a. I will give the formulation in 5 to 7 minutes, and then maybe I'll say the idea. Yes. So what is so now we can take yeah, this is again L plus as a Ivachori is the preimage of B of a barrel. So it's just you know, for SLN, it's like where you have if star denotes the positive well, I don't know, this is for SL3. So star denotes Taylor series, so the matrices where everywhere it's Taylor series, and here it's Taylor series under diagonal Taylor series with no positive term. So so now I can take, I fix some E in G of T, and full E is just the fixed points. And so E is usually, well, so in our case, E will be in exactly this matrix. It will be T times S, where S is a constant loop, which is also regular semi-simple, just a diagonal matrix with distinct eigenvalues.
You always contained in S2.
It's contained. Thank you. Yes, that's right. So example, you can, yeah, maybe do it as an exercise. It's example, so an exercise. Let's say if G is SL2, then full E is infinite chain of P1s intersecting like this. And there is a yeah, I should say that the centralizer X there, and the centralizer in this case contains a lattice which shifts this P1s. So mod lambda is just this. So the general structure will be always shaped, so it will have infinitely many components, but there will be a lattice acting modulo of the lattice. It will be exactly double your components, but components, geometry of the components, of course, will be much more complicated. They'll have singularities and all that. So actually here, the connection to the quantum group is very concrete. So just in this case, it's just there is a bijection between components and projective. Well, there's Kazul duality. So there's this projective modulus of the small quantum group graded, so that endomorphisms of each projective is cohomology of P1, and the homes are given by cohomology of intersections, but in general, it's more complicated. But okay, so yes, and so now here is the key point. So what is M here? The point is that M Delbour here is the you can take the T star of the flag variety, and you can take the Hamiltonian reduction with respect to, well, what we call P minus psi E. So what is going on here? So P minus is the congruent subgroup in G now of the negative loops, C of T inverse. So first congruent subgroup. So meaning the kernel of the gain evaluation map. To G. T inverse. So evaluation is infinity. And the point is that the Lie algebra, the pairing with E defines a character of this algebra, algebra and group. And we consider the Hamiltonian reduction with the corresponding, where we take Hamiltonian reduction is like you take preimage. Oftentimes you take the zero of the moment map, but here we take the preimage of D of that character. Okay. So this is the key point, and then full E is a Lagrangian in the symplectic. And so
so the map, moment map, MP goes from P minus to
P minus star. So MP goes to T star flags to the algebra. And well, remark so is that in the finite dimensional Springer theory, so for finite dimensional G, for every E, one can define the so-called experiment subgroups. We can define P minus in G, so that pairing with E is a character of the the algebra of P minus. So it's a unipotent group. So sorry, P is a bad notation. Actually, it should be called human. Actually, let me make this change because it's not. SGP minus is maybe this, but here I want to take U minus. Yes. Yes. And the slice, well, slot slice maps isomorphically to P star G mod B mod U minus say E. If E happens to be even, then you just take the SL2 grading and you take all the negative eigenvalues. But so for loop algebras, this construction, it doesn't have an analog for every E, but it has an analog sometimes. Okay, so I wanted to, so it's here one of the, yeah, so maybe now I can give the final formulation. Well, almost final formulation. So specifically, we consider P will be inside P will be inside the category of like perverse sheaves on flags on a affine flag variety, equivariant with respect to U minus psi. So we have a sort of reduction of character. So there are, and the general idea is that such shifts should microlocalize to that shifted kind of Hamiltonian to this shifted Hamiltonian reduction. So there is actually technical discussion here, which I thought I could go in, but maybe the time flies, so maybe I should make it brief.
No, we don't.
We don't?
Another half an hour.
Yeah, 2. Yeah.
Until we have had half an hour.
Yes, half an hour, yes. But okay, no, I'm not stopping here yet. But so okay, still in a few words, technically you actually should, I mean, if you learned about constructible shifts, you should complain about the meaning of this. So this can be defined in a tall setting. Okay, so some remark. Actually, yeah, I can make it brief. In general, so suppose you have some unipotent group. Acting on some smooth variety X. Of course, one can talk about equivariant. For any group, you can talk about equivariant sheaves, constructible sheaves on X. But now suppose like here, psi is from U to, well, let's say over C. That's an algebraic map, so additive character. And so we want to define like shift theoretic analog of things transforming by a character. So like sheaves, perverse sheaves or derived category of constructible sheaves on X U psi. So what you can find in the literature can do it in elladic sheaves on if X is over Q using Norton-Schreier sheaf, or in D modules using exponential D module. in constructible sheaves, there is no general construction, and I think this microlocal sheaves on this fiber of the moment map maybe should be taken as a definition, but assume there is a trick around this under additional assumption that there exists, that we have a C star action, an additional C star. Well, maybe let's put it this way, that the U action is extended to an action of C star semi-direct U. So C star X basically X on X and normalizing U. And the key point that C star dilates psi. Then there is a very nice definition, which now is context independent, which coincides with what you get here, here by using this series. Basically, the idea is that using the C star action, you can average, like, because of the C star action, things don't change when you replace psi by proportional, when you dilate psi, and then the average kind of story exists in this constructible world. Namely, then there exists a nice definition. So it appeared. So it was done. It appears in the Geisgers. Maybe it's so. Yeah, I don't know. Huh? Sorry. So this is basically, so we do have it in our situation. We do have it for every fine dimensional Springer fiber, and we do have it for our class of affine Springer fibers.
So what do you mean by C star extending to C star cross U?
So, well, there is some action. There is some bigger group which has this structure.
And that C star action also dilates the
Dilates.
Are you trying to describe on the formalism and covariant category on the Abraham side?
Yes.
Yes.
So they call it Kirillov model.
And you're saying that that formulation that you give can be reformulated in terms of these.
Yes, yes. And there is a nice, so it's actually some, it's not, one way to say it is that we take, yeah, it's just sheaves equivariant for C star semi-direct kernel of psi on X modular sheaves equivariant. Anyway, so that maybe I should not spend too much time. So this is the definition, and it's not like rocket science. In 15 minutes, maybe I should be able to convince you this is a good definition. Okay, so the case to consider is just when maybe A1 acts on itself or something like this, or A1 acts freely somewhere. Maybe an interesting case when A1 just C plus acts, yeah, on the product C plus with something, and then if you consider in this example, you can see how it works. The point is that there is a natural microlocalization to exactly where I want, to microlocal sheaves on this T star X. Okay, so now I almost get a formulation. I can say a few words about the idea of proof and also about the final formulation. So idea. So proof follows actually from two facts. One obvious fact, which are one obvious and one previously known. So the obvious fact is if I consider the sheaves on the flag variety mod u minus psi, then this is the isomorphic equivalent to the category of vector spaces. This is just saying that, just look. Sorry. No, that's not. What I want to say is that if I take here Affine-Grassmannian, so Affine-Grassmannian is LG modulo L plus G, which already appeared. So it parameterizes. Yeah, I didn't say that. The affine flag variety parameter for GLN parameterizes periodic flags of lattices, and this just parameterizes lattices. But look, so the point is just that LG and U minus are complemental. I don't know, part of a Riemannian triple or so the Lie algebra of the loop group, so L plus G, the Lie algebra of the loop group is a direct sum of the Lie algebra of L plus G and the Lie algebra of U minus. So accordingly, there is just one open orbit of U minus on this quotient. And it's easy to see there is just one sheaf like this kind of thing that, this is the most basic idea here is that if you have something transforming by a character and the character is not trivial on the stabilizer, then it has to be zero. That's old and powerful idea. And so the point is that for the things are also that for Grassmannian, there will be sorry, actually, I'm lying here a little bit. It's not. It is basically this, but it will be. It's not. It will be rather. There will be other. I mean, there isn't one open orbit, but there will be other relevant orbits, as they say. But still, the category has very simple shape. There are no. There will be a bunch of. So the corresponding, yeah, it's not obvious, but it's still easy. So the point is that if you take the T star Grassmannian and you take that, you reduce that by U minus psi, then instead of this Springer fiber, you just get sort of a discrete set of points. And accordingly, this will be a discrete set of points in bijection with lambda. This just corresponds to, if you read the fixed points of that element S on the Grassmannian, so the lattice is preserved by S. And well, just it has to be like compatible with the standard basis. You have a basis of eigenvectors of S, and you can multiply it by various powers of uniformizer, and that's all you can get. And so kind of here you get microlocal sheaves on this discrete set, but this is of course just the same graded vector spaces, and it's not so hard to check this. Sorry, I was thinking about some differentiation. Yes. And then there is a known fact that if you take well, just not even there, but this old realization from this ABG paper, it's also other proofs from the Lustig program that perverse sheaves like I equivariant on the Grassmannian let's say, derive di equivariant of the Grassmannian. Well, this is maybe let's first say I naught, where I naught is a unipotent radical. So this is basically the same category that appeared before. So the row sheaves. So here it's the same as well, modules over the big quantum group, which is not very far from the representation of the small quantum group. So if you write what I started writing, the I of the Grassmannian is for n tilde 0. And then from these two facts, you kind of do some sort of tensor product of categories argument. So in fact, concretely, so this P inside inside the D of flags mod U minus psi is generated under the affine Hickey action. So here we have an action under the I of flags by the object kind of that I talked just about. So by pullback of the sheaf from the Grassmannian coming from the open orbit, and the open orbit Grassmannian. So that's actually the definition of the category, and then you can then we check that this microlocalization functor to that I just sketched is an equivalence to. Okay, so maybe so sorry. So what about this tensor product argument? So basically, what happens here is
So you don't see it explicitly as an equivalent of their pair of algebra lines that come.
it follows, no, but we kind of bootstrap from this known information. You can rephrase it this way, but yeah, we don't. It's not too explicit.
I mean, the derivable, I mean, the actual.
So basically, what I'm trying to say is that is D of LG mod L plus G mod I. Actually, I wanna write it this way. Tensor over D of LG mod L plus G L plus G with D of LG L plus G and I minus psi. So this should be heuristically clear, and there are general results along these lines, but you know, kind of this allows to cancel this, and then we can. And so we have in the right hand side we have coherent description for everything involved, and that's how. So this is like point mod T check. And here, this is known to be like 0 times. So this is derived Satake. And here we get and when we take this fiber product, we recover produces. So in a way, there are more complicated but known things. So there's a little bit maybe of a decouple method, right? And pour out the water and reduce the problem to the one solved already, but okay, so so yeah, that's about the proof. Oh, so yes, so I don't have I think it's perfect timing, so I'm just yes, so yes, so the final statement is that we actually define this, and well, there is a I said it's a category of sheaves, but it's the category of sheaves that subcategory here. You can say so P be the pair of sheaves in the subcategory generated by the spherical, unique spherical sheaf, the sheaf pulled back from the one, well, from the generator in D of Grossmanian, of like Grossmanian, how do you minus sign? Then, first of all, P. No, it's not the whole. So, but it can be characterized. P is equal to the set of F in pair of sheaves on flag mod U minus psi, such that this shifted singular support defined using Kirillov model is contained in full E. So there is this characterization. So this is then, so this is the first statement, and then P maps isomorphically to this microlocal sheaves on M double supported on E. And 3P has this description. P is essentially A prime. Modules over A prime with supported at 0. So this is causal dual to A. So this is the full statement of the theory and the theorem, and then the indicated the proof. And okay, so let me finish by saying the method. So in this available paper, we propose a more general conjecture. And in fact, but so there is a conjectural generalization to all homogeneous affine Springer fibers, and then there will be some Betty space on the dual side. So see the paper on the archive. the same, the proof should generalize not to prove this conjecture, but still for small slope, for E of slope, I think less ripple than 1, where anyway, so there are some cases of this conjecture which should be covered by the same argument. But okay, so maybe that's a good place to stop. Maybe, okay, so just one remark here is that one should, easy example of a affine spring fiber is obtained this way, that you just take important and lift it generically to a loop group, and then the affine spring fiber appears there as a just union of components. And a simplest example of one of the simplest kind of cases of Springer theory is if E in SLN is a two-block nilpotent in SLN. In this case, the whole components are smooth and they are just P1 bundles, and so that's, everything works nicely. But this theorem doesn't cover all, it covers some cases of this type, but not all of them, because the lifting it may be kind of easier to analyze it by other methods. By this method doesn't always apply because they may not be homogeneous. So they are homogeneous, for example, for equal blocks.
So what is homogeneous?
So homogeneous, yes, I keep using this. So it means that, so you have loop rotation acting. And the requirement is that you get something which is conjugate to your important up to scaling. So here it's just, so ST was obviously eigen space of loop rotation. So you scale T and then, so this is the case. So this is what allows to, there was this technical point in just defining the category. So for this you need cis direction. And there are other places where it comes natural. So in this paper about Hodge theory, it's used a lot. But yeah, so E tilde is so the homogeneous for equal block case for equal blocks, but not in general. Even for two block case. Okay, so the other questions?
So, I'm not sure to which extent our settings over, but we do expect that for all Coulomb branches, there will be well, firstly, for essentially all Coulomb branches that are smooth, we can one should be able to generalize our proof for Coulomb branches of AB equivalent to generic Coulomb branches, and then there you get a proof of homological mirror symmetry for using your category of.
Yeah, I think for type A this should be, yeah, I think your space for type A should be this, your spaces should be those spaces for type A.
And so there it's from the A model perspective, it's not surprising that there are two ways to generate the category, either via the object that I've mirrored tilting bundle, or by your kinds of guys, I guess we call them the I-brains.
So what are I-brains?
Well, it's a big, so if you simplify it,
Yes.
the guys are mirrored to tilting bundles of symbols of a potential, and so they say symbols of some downward gradient flow. And for every symbol of a downward gradient flow, there's a symbol of the upward gradient flow. So then, in other words, there's a dual symbol. And the duality between them being sort of a model for Cazul duality, in that if the original your generators were projective, they're dual, the simplest for the same algebra.
I see.
And what would one want there is, well, the devil of the difficulty there is you have to be very careful about what it means to actually generate. In other words, the potential done generically, you have to include critical points in infinity where the argument fails. But what one could hope there is to translate the question into why is Cazul duality a quadratic duality, or if it isn't quadratic, what replaces it? In other words, the generation part, once properly formulated, is kind of the obvious thing. The sort of the more miraculous thing is why should these algebras be quadratic dual or something close to that?
Maybe we should discuss it. I don't have any immediate reaction. So, but thanks for the question.
Maybe a quick question. So when you say the Microlocal sheet, do you mean the wrapped version of the Microlocal sheet?
No, just the ordinary. There is a way to so here, there was this thing supported at zero section, and you can get away from zero section by considering wrap category, but that's
if you were to include a potential, your category, those potentials would have to have poles and you.
No, but so here that's right. So, but here we work with cycles, compact cycles, and so we don't need the potential.
But how are you going to get it graded?
Well, kind of we don't. But okay, so thank you. Let's see if people.